Okay, here's the first question. I want you to read it, do it, and then come back and see what I did. Now, oh, by the way, they want you to show all your work. So I'm going to do everything. Okay, there you go. And there it is. Multiply, remember? Multiply. There you go. Multiply, 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 multiply. And then add them all together. So your expected value is 3. And then don't forget, a lot of times we forget, interpret what that means. So in other words, the expected outcome of this investment is $3 million. So I would say if you're investing more than $3 million, it's probably not a good investment. If you're investing way less than $3 million, then yeah, I would probably go for it. Now remember, this is what happens over the long run. This isn't exactly what's going to happen, but this is what we should expect to happen. Could be a lot different than 3. Okay, there it is. The next one is, as you could probably guess, find and interpret the standard deviation of x. So I'll do that one on the next slide. Okay. Okay, so I am going to calculate the standard deviation by hand the long way. So I'm actually really glad that Eric asked how do we do that a couple different times. So hopefully you were paying attention. If not, here it is. Now, what do? We take our value, right, minus the mean, and we multiply it by the probability, and we add them all together. And we do that 4 times because we've got 4 values here, and then takes the square root. Okay, there it is. So remember, 1 minus the mean times the probability. It's all right here, right? 2 minus the mean, multiply that by the probability, and we go all the way through all that stuff. So I'm going to add all that stuff together first. And I kind of ran out of room, but it's 6.4. 6.4. Whoops, 6.4. Okay, but that's the variance. Don't forget, we got to take the square root of that to get our standard deviation, which is 2.53. Okay, so if we want to interpret this standard deviation, what does that mean? Well, we have an expected value of making $3 million, but it could be plus or minus $2.53 million. So on the low side, you could only make 0.4, like 400,000 on this thing. So it's a fairly big standard deviation considering that the expected value is 3. The standard deviation is almost as big as the expected value. That's a pretty big standard deviation. Okay, that's how I am interpreting this. Plus or minus $2.5 million on either side of our expected value of 3. So you would have to write something down along those lines. Remember, more is better as long as you know what you're talking about. Okay, let's do the last part. And I'll show you what that is. Okay, go ahead and read this question and see if you think you know what to do from there. Then stop the video. And okay, now if you got a chance to think about that, the term linear transformation, that's just a fancy way of saying what's the new mean and new standard deviation. That's it. So don't get thrown off by that. Now, they could have just said this first part about the capital fee of $200,000 and the profit of 10% and left it at that, but they're really nice and said they actually wrote it out for you. Now, all we got to do is figure out the new mean and new standard deviation, and I think you guys are pretty good at that. I'm going to write that out right now. And there it is. They don't ask you to interpret this in this case, but based on those new constraints on your investment, that's what your new expected value and your new standard deviation would be. Okay, let's try the next question. Okay, read this one, think about it, then I'm going to do it. Well, this one's kind of tricky. So look out. We're taking our sample from the same population. So what is the expected difference? Well, we expect 266, right? That's our expected value for both of them. So when we subtract them, we get 0. So our new, I don't know, I'll just call it x minus y, should be 0. And then what's our new standard deviation? Okay, 16 days, right? So we're going to do, well, we don't subtract them, we add them. It is 16 squared plus 16 squared. Add them together, take the square root. That is our new standard deviation. Okay. Come on, equal sign. What's up? There you go. All right, hold on a second. Okay. There you go. That's the answer to letter A and letter B. Now let's look at letter C. Find the probability that the difference of the lengths of the two pregnancies is greater than 25 days. Okay, I think we know how to do this. Let me move some stuff out of the way. Now, z-score, right? We're going to take 25, which is the difference we're interested in, minus our expected value, the mean, divided by the standard deviation, 22.63, and we want to know what's greater than that, right? Okay, that's going to be our z-score. Okay, so our z-score is 1.104, and I think we're getting used to where to go on the calculator a little bit. Normal, CDF. So I always draw this picture. Let's see, what is it going to look like? It's going to look like this, right? And we want to know this area more than 25 days. So you do the normal CDF, but remember, that's this area down here. So subtract from 1, and you get 13.479, or 0.13479. Okay, so this is approximately, let's see, where is it? 0.1347. Okay, there's a 13% chance that they last more than 25 days. But here's the tricky part about this one. What if you happen to reverse the order of when you subtracted them? So, you know, if you have a long pregnancy minus a small pregnancy, a shorter pregnancy, you get 25. But what if you had a shorter pregnancy minus a longer pregnancy? That would give you a negative number. They're still 25 days apart. Aha! So you have to think about this. It's on both sides. So all you got to do is double this. Okay? So this side and this side together, which gives you, what is it? It's 26 point something, 26.92. 0.2. What is it? 26. Whoa, what just happened? 0.2692. Okay. There it is. So, there's that. Okay, read this one. See if you can get a handle on it. Now this one has to do with binomial and geometric probabilities. As I read through the whole thing here, thought about it. Now if I was to do this on the test that we're going to take in the spring, I would probably write out some stuff about bins, you know, to show that it satisfies the requirements for a binomial probability or a geometric probability. So just to be as complete as possible. But for where we are right now, let's just take a look at this thing. Pete throws a dart, his first bullseye. Find the probability that his first bullseye occurs on his third throw. Now that is a geometric probability. So I just write this out like this. We've got 0.7 is the fact that he hits the bullseye, and 0.3 is the fact that he misses the bullseye. So he missed the bullseye twice, hit the bullseye once, multiply that out, and you get your answer. So there you go. It's about a 6% chance that might happen. Not very likely, but not out of the question either. Okay, now the next one. What is the probability that Pete hits 5 or fewer on his next 10 shots? Now, I could have used geometric PDF on the letter A. And remember, second vars go all the way down past Poisson to get to geometric PDF. Now this one is binomial. Let's see, is it PDF or CDF? What is the probability that Pete hits 5 or fewer? So it could be 5 or 4 or 3 or 2 or 1. So we're going to do binomial CDF. Okay, CDF, binomial CDF. And so our trials are going to be 10, right? The probability is going to be 0.7, and the x value that we're looking for is 5. And this tells us 5 and 4 and 3 and 2 and 1. It adds them all up for us. That's the difference between CDF and PDF. Okay, so I plug that in to the calculator, and it gave me about a 15% chance of that happening. Okay, now let's look at letter C. Pete forgets his eyeglasses one evening, but he's confident that it's just as accurate without them. Okay, now this one, on the 10 shots of the first 10 shots of the night, he hits the bullseye only 5 times. So it doesn't say 5 or less. It says exactly 5 times in this situation. So this is binomial PDF. Okay. So again, I'm going to plug it in the calculator, and it's going to give me the answer. And it's still the same. It's 10 trials, probability of 7. We want to hit 5. But because it is PDF, that gives us the exact value for that one. Okay, so I plug it in, and this is what I get. 0.1029. So about a 10% chance of that happening. Now, does this mean that his eyeglasses are important? Not really, because he had a 10% chance of that happening. It's not out of the question that that would happen, with or without his glasses. Okay. Also, to be complete, I might write out the formula by hand to do this problem if I was on the big monster test, right? So 10, choose 5, and we say 7% chance of success and a 3% chance of failure, both 5. And like I said before, when we're talking about this is the same as this, these two add up to that, and that still gives me the same answer. All right, that's it, and I will see you on Monday. Bye.